So here's an example of modularizing a program by making a function. Have we seen this slide? No? Okay, good. Here's a program that needs to print out the company's address. And say you write so many programs that you're going to be printing out the address in a whole bunch of different ones, it would make sense to put it in its own module, in its own function. And then you could put an import statement in each program that needed to use it, and then you could just call that, with one line of code. So this flowchart looks a little bit different than what we do in class, but not much. It has a section up here called declarations, which we don't need. In this language, you don't have to declare your variables before you use them. Now sometimes you have to initialize one to like 0. If you're going to write something that sums up a whole bunch of numbers, then you have to set it to 0 beforehand. But you don't need a declarations block in our flow charts. But the source that I'm modifying in order to produce these pages does show that. Not a big deal. So anyway, start and then declare our name and our balance. Then input the name and the balance. There's another difference between what I like to do and what the book shows, is I think that putting two different commands in the same block is not a really good idea. Input name and input balance should be two different blocks. Anyways, the real point of this one is the module. And here it says display address info. What that does is it calls this function, which is a separate bit of code. It's got its own, it starts with a DEF keyword in Python. It's got its own indentation level, and it's got a return statement at the bottom, or at least once it's stopped being indented, that's where it returns. And what it is it's its own self-contained chunk of code that can be called anywhere in your program. And in this case, they declare a couple of variables. One called line 1, which is the name of the company. One called line 2, which is the address. Line 3 is the rest of the address. So it stores all that, and then it outputs line 1, line 2, line 3, and then it returns. Now here's what I mean by about putting multiple things in one block. Why did we put two commands in that one, and then we break this one into three? But anyways, and then it returns, which means it comes back up here, and it continues on its merry way from where it was. So then it prints out the customer name and then the total. So here's what the pseudocode for that would look like, according to the text. I may modify my processes to have a declarations block. Anyways, here's our program, our main program, the left side of the flowchart, which declares the variables, the name and the balance. We input the name and the balance. We display address info. That runs down here and does all this stuff, which assigns these three variables and then outputs them and then returns, which comes back up here and outputs the customer name and the total, and then it stops. So this matches that. A couple of things to note. Variables and constants are only usable in the module in which they are declared. So if I launch Python, if I launch idle, give you a demonstration. If I do this, I'm just going to declare a function called sample. That's all it does is print, this is a sample, whatever. And then down here in our main code, I'm even going to put a comment that says this is our main code. I'm going to call sample, and then I'm going to try to print A. It's not going to work. It says A is not defined. Well, yeah, it is. It's defined right there, isn't it? Well, it's defined in its own function. It's like that's a bathroom in somebody else's house. You can't use a bathroom when you're in your own house. That's a really stupid simile. But, you know, you can't use the furniture that's within somebody else's house. Anything defined within sample is only accessible within the sample function. We could print it out there, but we can't print it out here. If you want access to something both here and here, you have to do one of two things. You either have to pass it in or you have to return it back out. Passing it in is like putting something in the door. You know, you're walking through the door in order to get into the house, and returning it's, you know, you're carrying something back out when you leave. So if we wanted something passed into here so that we could, you know, use it in a calculation and a conversion or something like that, we would pass it in. And then if we needed that value back to do something down here, we could return it. So I'll give you an example of that. We're going to modify sample and call it sample 2 just by cutting and pasting. But sample 2 returns A. So when I call sample 2, I'm going to do this. A is equal to sample 2A. Now it will print A, which is equal to 10. We got that value out of the function. We wheeled that couch out of that home, put it on our front yard so we can sit in it. So this data was declared in here, but we passed it back out. If you think of each function as a block, a box, anything defined within that box stays within that box unless you have a return statement. And the only way you can get data into that box is if you cut a hole in the top of the box and pass it in when you call it, which is when you have parameters up here. So let's write an example of a function that takes a parameter. I'm going to call this one triple me. It takes a number and returns 3 times that value. Result is equal to 3 times n. Return result. So now I'm going to call triple me. X is equal to triple me, and I'm going to pass in 10. We ought to get 30 back out. So when I print it back out, I hope to see 30. And it printed 30. Good enough. In this language, and in a lot of languages, not every function has to have a return statement. If it's not passing a value back out to be used elsewhere, code-wise, you don't have to stick a return statement in there. It assumes that the first unindented line of code marks the end of the function. So this is one entire function, and since this is unindented, it pretends that there's a return statement here. You know, you can go ahead and add that return statement. I kind of like doing that sometimes, but it adds a line of code, and you know, usually I'm trying to fit as much on the screen at the same time. When we flowchart it, though, we do always stick our return statement at the bottom. So I kind of like putting it in the function as well. Some languages like Java give you a warning saying, you don't need a return statement there, but here we like it. Okay, I hope that makes sense. I hope the idea that anything defined within here cannot be used down here unless it is passed back. There is a way to define something that is useful for every function in the code. That's called a global variable. We'll talk more about that in a little bit. So variables and constants are usable only in the module in which they are declared. Programmers say that the data are visible or in scope only within the module. Okay, you're looking through a scope. That data is only available right there, whatever you see through the scope. If you try to use it outside of scope, it doesn't work. This variable right here, its scope is limited to this function. Can't be used outside of it. That's why we got an error when we called it down here. Here's another thing. We're going to define Fred, just in another example. B is equal to 10. And then we're going to define Barney. You don't necessarily need to type these silly examples unless it's just helping burn it into your brain. So here we go. B is declared within Fred. its scope is limited to the Fred function. So we can't print it out here. That flat out will not work. It doesn't matter if we call Fred before we call Barney. This thing appears and disappears inside that function. Just like the furniture in somebody's house. You walk out of the house, you can't see the furniture anymore. You can't sit on it, whatever. Another way that is said is that those variables and constants are local to the module in which they are declared. So in our source code, our flowchart up here, line 1, line 2, and line 3 are local to this function. Can't be accessed anywhere else. So a local variable is one that's defined within a function. It can only be used inside that function. One of the motivations for creating modules is that the modules are easily reusable in multiple programs. If I need to display address info in several programs, then I could just do an import and then call that function anytime I want to from any program that I write. It makes the modules more portable. They are self-contained units that are easily transported. That's why that data is defined within it. And then if your company's address changes, you only need to change it in one place rather than everywhere where you printed it out. So besides local variables, keeps talking about constants, and we haven't even talked about constants. You can create global variables. Global variables are known to the entire program. They're defined above the functions. This means that they're visible to and usable in all the modules caused by the program. So I can come over here to my code. I'm going to define a global variable. I'm going to put a comment that it's global. Say I decide that the value of pi is equal to 3.14. Not very useful. Not very precise, I mean. But now that it's defined up at the top, I could print it out anywhere in this. I could use it in any function in here and down in the main code at the very bottom. So A is a local variable. It's stuff that's inside your house. The global variable is accessible to any function within this file. So let's add some comments here. A local variable is defined within a function. It is only accessible inside that function. A global variable is defined outside of the functions in the file. It can be accessed by any function in the file. Now, as you program and become more sophisticated programmer and work on other languages such as Java and C++, you get away from the idea of a global variable and instead you come up to the idea of a class variable. But the concepts are very similar. So when do you modularize your program? Depending when to modularize a program does not depend on a fixed set of rules. There's no law that says, oh, it's time to modularize it. That's up to you. It requires experience and insight. Programmers do follow some guidelines when deciding how to break down the modules. Some companies have arbitrary rules, such as a module's instructions should never take more than a page if you print it out. Why is that? Because if you printed it out and it took several pages to look it over, then it'd be harder for you to explain to somebody else what it did. It'd be harder for them to keep it in their mind or whatever. Or a module should never have more than 30 statements. Or never have a module with more than one statement. Well, that last one kind of makes sense. If I just had this, Barney, print B, why wouldn't I just print B right there inside the program? Why would I go to the trouble of writing a function and calling it if I could, rather than do this, Barney, I could just do the print B right there off the spot, right there on the spot. Especially since since Barney is a broken function anyways, it doesn't work, relies on a variable that it can't get a hold of. Anyways, when do you modularize? If you find yourself repeating code in your program, that's a good time to modularize. I think we wrote a flower drawing routine. It took about 6 or 7 lines of code, and we drew 4 flowers on the screen. We could have cut and pasted that code. Copy, paste, put it in there 4 times. Pretty much any time you have that code, a repeat of code, certainly more than twice, but even twice is pushing it. You want to make it a module instead. Why? Because if there's a mistake in it, or you want to change some functionality in it, you only have to change it in one place. What if we wanted the ability of the flower to have filled-in petals? Well, if we had 4 copies of the flower drawing code in our program, we'd have to change it in 4 different places. What if drawing flowers is really important to us and we used it, in hundreds of different programs? We don't want to have to go and change that code in 100 different places. Instead, we want to write the function once and then use it as many times as possible. So a better policy is to place together statements that contribute to one specific task. Drawing the flower was one specific task. Doing a conversion, like going from pounds to kilograms, could be one specific task. The more the statements contribute to the same job, that's called cohesion. If you do 2 different things in a function, like if you have a function that both asks for input from the user and then does a conversion of it, that function kind of has, quote, low cohesion because it's doing 2 different, conceptually different things in the same function. It's better to break it up so that you do your input in one place and you do your calculations somewhere else. Because then you may want to change the way the questions are asked and you don't have to mess with the conversion function or vice versa. And when you're writing large programs, you may distribute these functions in a lot of different places. And you may use something that's called source control. Source control is whenever you want to make a change to your program, you have to unlock that piece of code. You make your changes and you check it back in, and the source control keeps track of every change you've made to it. So that if you broke the code, you can roll it back to a previous day, and you can compare the versions and find out what your mistake was. And if the functions have low cohesion, if they're doing too much, if they're doing dissimilar tasks, then it makes it much more difficult to do that kind of thing. 2 people may need access to that function at the same time in order to make changes to it. Okay, I lost where I was. So a module that checks the validity of date, because you could enter February 32nd as a date in your program. And in order to check that, your program actually has to do some calculations. It has to check, both the table of the number of days in a month and to make sure that it's not a leap year. And the rules for leap years are kind of more complicated than you'd expect. Leap years come every 4 years, except if the year is divided by 100, except if the year is divided by 400. So year 2000 had a leap year that repeats only every 4 centuries. The year 2100 is not going to have that leap day. The year 2200 is not going to have that leap day. So there are rules. And is our software going to be around, that many days? No, not really. But the idea is right. You want to validate the date. It depends on knowing both the month and the number of days for every month. So that's actually not a super simple calculation. You would want to not have to do that in 20 different places in your program. You'd not want to have to write that code and copy it. Instead, you just write it once. And as long as that's all it's doing, it's cohesive. Now, if you wrote a module that checks the date validity and also deducts insurance premiums and computes federal withholding tax, that would be way less cohesive. That's one module being overly ambitious. And it's like hiring a drummer and he's also out there, doing your gardening and whatever. Just way too much. Now there's an example of a loop. I'm going to skip that for now. Okay, no, we're not. Generally, programs will start to follow in your mind a very specific pattern. At the start of your program, you'll do any necessary declarations. If you have to declare any constants or any interest rates or something like that, you put them up there. And then if there's any, quote, housekeeping, like opening a file or opening a connection to the internet, you will do that. Then your program will loop over and over and over until the user decides it's done. Or until you reach the end of the file. You're processing all the test scores that are stored in a file. It keeps looping. Finally, it's done, and it does whatever cleanup it needs to do down at the bottom. Like it needs to close the file, or it needs to print the results out, or it needs to, save the data to a server on the net. So this is a very common pattern. Stuff you do before the loop, then you do some loop, and then you do the stuff after the loop. Now this becomes way more important when you're manipulating files, because you have to open the file before you can do anything. And then you should always close the file when you're done doing it. But looping is what programs are really all about. Those computers that calculated trajectory tables, for artillery back in the 1940s, just printing out one of those would be a real drag. You could just hire somebody with a hand calculator to calculate that by hand. Instead, you'd want to print out an entire table of them. You wouldn't want to just calculate one person's paycheck like we've been doing. Instead, you would want to run through and print out everybody's paycheck. When you're playing a game, you don't want it to draw your character on the screen and then exit immediately. Instead, you want to keep the character on the screen and let you move. That's all looping. So a lot of tasks follow the 3-module format. Not just programming tasks. A candy factory opens in the morning. The machines are started and filled with ingredients. That's the housekeeping. That's the start of job stuff. Then, repeatedly during the day, the candy is manufactured. It could take a whole bunch of different steps to do that, in which case you might put that in its own function. If you ever run out of ingredients, you run out of sugar or chocolate or whatever, you're done, or it's time for people to go home, then you're done for the day, and you can clean up, you can do the end of job stuff, put everything in the boxes and ship it out or whatever. Just kind of think in that process. What do I need to do at the beginning of my program? If I need a loop, what I'm going to do in the loop, and what I need to do at the end of the program. Not all programs take the format of the logic shown in the previous figure, but many do. Have we written a guessing game program yet where the computer picks a number and we have to guess it? No. Yay, nay. Okay, that's what we're going to do. That's our in-class, our real one. So I'm just going to put some comments here. Startup tasks. There's not going to be a lot of startup tasks in this case. Loop until done. And then final tasks. So for our guessing game, we need to pick a random number. The computer needs to. Pick a random number, say between 1 and 100. Then what are we going to do? Loop until done. What does this consist of? Well, it consists of asking the user for a guess, comparing it to our secret number. If they get it wrong, tell them so. Otherwise, the loop is done. And then the final tasks. Tell the user they won and tell them how many guesses it took. Now for us to do that, now that we've thought about it, we need to go do something else up at the startup tasks. We need to initialize a counter, how many guesses they've made, or turns. Let's call it turns. So I'm going to change this word from guesses to turns. And while we're looping, we need to add one to our turns. So I'm going to use the fancy word increment. Increment turns. That just means add one to the counter. And then up here, under pick a random number, I'm going to initialize turns counter to 0. Okay, I know I type way faster than y'all. These are comments that are going to guide me. It's like I wrote pseudocode for the program. Probably to be strictly correct, I should write this as pseudocode. So, I'm going to open Notepad and do that. Start. Tab. Set random number. I'm going to change the syntax of this to set secret number. Alrighty. Then set turns equal to 0. Loop until user guesses the number. That's way too vague. We're going to have to figure out what mechanism does that. In order to have that happen, I'm probably going to need to initialize a guesses variable and make sure it's not equal to the secret number. So set guess equal to 1,000,000 to -1, something that our secret number will never be. Okay, so once we're inside our loop, input guess. If guess not equal to secret number, print wrong. We're kind of rude. And then we're going to increment turns. Turns plus equals 1. And that's about enough. Then the final task will be to print how many turns it took. Print or output turns. And output a U1 message. So I'm going to put that above that output turns. Output U1. Then our final stop. So this loop until user guesses the number, that's kind of nice and descriptive, but I'm going to change it to be more logic rather than just description. Loop while guess not equal to secret number. And I could even take that word loop away. I'm just going to accept the fact that the word while means loop. All right, I think that's enough of a pseudocode to actually write the program. There will be some improvements to the program we could make. But let's live with this for now. So I'm going to dock this on one side of the screen. Get idle going on the other side of the screen. It's okay if you don't have all these comments. It turns out that there was a third step, which was to set our guess, what the user is going to type in. We have to initialize it. Oopsie. So I'm going to do the same thing the textbook did and just call it declarations. Secret number. We don't know how to make a random number yet. Maybe we've done it before, but I'm not sure that we have. So I'm just going to hard code the secret number to 25. Hard code means you just enter a number that really should not be fixed in the code. It'd be pretty boring if the game always picks the same number. But for right now, that's okay. Turns is equal to 0. Guess is equal to -1, or any value that the secret number will never equal. All right, I'm going to run out of space on the screen if I keep all these comments here, so I'm going to put this next thing above the above that stuff. While guess is not equal to secret number, we could just say secret. That would be easier to type, but I'll just go with what we went. Well, of course, the first time we go in, the guess is not equal to the secret number, so it's not like we're going to get locked out of it. Because when you write a while statement, if this condition is not true, it won't even go inside. It's like an if statement. Okay, so we need to input. There's always 3 steps to getting a numeric input. What are they? Y'all are killing me.
Asking the user.
Yeah, you ask the user, which means what do you do? Our 3 commands, our 3 lines of code are going to be print, input, convert. Right. So print, guess the number. And then guess is equal to input. And now let's convert it to an int. Hopefully they're not going to start guessing numbers like 100.1 or 98.3 or whatever. So we want a whole number. So we've done that step, input guess. Now we need to check to see. If they make the wrong guess, we're going to print the message that they got it wrong. If guess not equal to secret number, colon, print wrong. Try again. Now we're going to stop indenting. There's one more thing we need to do, which is to increment our turns counter. Turns plus equals 1. That means the same thing as turns equals turn plus 1. You don't have to add that comment. Just reminding you. Okay, we are done with our while loop. Now we need to do the stuff at the end, which is to tell them that they won and how many turns it took. So, final task. Print, you won. And then print, guesses, colon, followed by turns. This could be worded better. You know, it took etc. guesses. It took this many guesses to find it. Okay, I'm going to save this and I'm going to call it guessing.py so I can run it. See if I have syntax errors. Guess the number. Well, I know what the number is, but I'm not going to try to guess it on the first turn while I'm testing. 1. Wrong. Try again. 99. Wrong. Try again. I start getting desperate. 2, 3, 4, 5, 6. I'm going to get it right. 25, and it says you won. Guesses equals 5. Maybe it'd be neat if you got it on the first try. It gave you, a special reward. Said, you got it on the first try. You're psychic. But that's good enough. But the game's not really very fun yet. For one thing, secret number needs to be a random number so that we don't know what it is. And what else would make the game better? When you're guessing, you don't just want to know that you got the wrong guess. What other information would be useful in order to make your next guess?
Too high, too low.
Exactly, too high or too low. So let's get the random number part going first. And I'm going to Google it to make sure I get it exactly right. Random int Python, not Python, Python 3, those are the words I'm looking for. Okay, we're going to have to do an import random, and then we're going to use the word randint to get our random number. So up here at the very top, our first startup task really is going to be to do an import. So import random. Random is the name of the library we're going to be using. This comment is now kind of useless. I'm going to delete those 2 lines. They're just cluttering up the code. Now instead of secret numbers equal to 25, that's going to be random dot randint 1, 100. And honestly, we ought to tell the user the range. So we're going to add a print statement before our loop. Print, I'm thinking of a number between 1 and 100.
A whole number?
Whole number, yeah. I mean, if they had to guess pi. Yeah. So let's tack that on there. I'm thinking of a whole number between 1 and 100. Excuse me while I close that so I can run it again. Guess the number. 50, 25, 1, 90. Alrighty. We have to have some kind of hint. So just like you said, we need to change the program. So we're going to use some if statements, or elifs, right here underneath that if right there. But I want to make sure that everybody's got it working up to this point. So pause. I'm going to comment out that. So we need to let the user know whether they need to guess higher or lower. So instead of just simply saying wrong, try again, let's put an if statement there. I'm going to comment out that print statement, that wrong, try again. We're going to modify it a bit. So then we're going to say if, don't need the parentheses, guess is less than secret number, colon, we're going to print a message, nope, try a lower number. Wait, that's not right. That's inverse logic. This needs to be if secret number is less than the guess. Right? Yeah.
That's if guess is below, you need would be a higher number then.
Right, so let's just change this. Nope, try a higher number. Else, colon, print, nope, try a lower number. So I'm going to start smack dab in the middle, 50, nope, try a lower number, 25. When you run it, your number should be different. All right, took me 8 guesses. If you play a perfect game of this, never duplicate numbers and always go for halfway between the 2 points, there's a mathematical calculation you can do which would calculate the exact number. You know, we could change this from 1 to 1,000 and it really would not take very many more guesses than it did for 1 to 100 because that lower and high lets us eliminate, you know, half of the range each time. If it was between 1 and 1,000, you'd guess 500. Nope. You'd guess 250. Nope. You'd guess 125. Nope. That's like 3 guesses to get it down to like a range of 100 numbers, which is where we are now. So the maximum number of guesses it would take would be like 3 more to go from 100 to 1,000. I forget the exact calculation. It uses logarithm. Let's see if we can guess it. Just a sec. Log 2 of 100. Okay. It should take between 6 and 7 guesses at most to guess a number between 1 and 100. If it's 1,000, it should take fewer than 10 guesses. If it's 10,000, it should take fewer than 13 guesses. You can see that this method of dividing in half each time is a really efficient way of narrowing down data. This is called a binary search algorithm. Although we're not really doing a search here, instead we're just doing guessing for a random number. If you had to search, you know, 1,000 things that were lined up in order, then it would follow the same mathematical sequence for determining the maximum number of guesses. All right, there's our program. Is there any reason to modularize this? I'm looking at it, and is there any duplicate code? Did we ask any questions more than once? Did we do any calculations more than once? And really, no. The only thing that I see as duplicate is just this line and this line. And I don't really feel like that necessarily needs to be modularized. However, in the last 15 or so minutes of class, I want us to draw this as a flow chart. It'll be good flow charting practice. Did everybody get this working? Everybody remember their Lucid chart password? Let's go into Lucid chart. lucidchart.com. Alrighty. All of our, oh, that doesn't look good. There we go. All of our flowcharts need to do a start and a stop. If you're flowcharting a function, instead of start and stop, you put the function name up in the oval and a return down at the bottom. But there we go, start. I'm going to take a considerable amount of trouble trying to get everything to fit on one screen, which you absolutely do not need to do. That's my problem, not yours. Okay. So what's the first thing we do? We do some declarations. We need to calculate these things. I'm going to put that in a process block, getting the secret number. Secret number equals random between 1 and 100. Yeah, I could have just put in that line of code there. But if you give this flowchart to somebody else, they're not going to be thrilled if you put some code in your own language and they're going to rewrite it in C# or Java or something. So we also need to initialize turns and guesses. Whenever you're just initializing data to hard-coded values, it really is kind of okay to put those in the same block, just like the book did. Turns equals 0, and I'm going to hit Control Enter to make it go to the next line. Guess equals -1. Now, whenever I demonstrate putting more than one command in the same block, people start going way overboard on that. Don't carry it to extremes, but if it's just initializing two variables, initializing means, giving some values, some variables a starting point. It's what the textbook called declarations. Then we can do that. Why did I not put the secret number one in the same block? Can anybody guess why?
It's not defined as a number yet. It's still-
Yeah, this is like really different conceptually than this. This could take several steps, and it did. It took an import statement, it took calling random.int, and stuff like that. It's not just giving a 0 to a variable or a -1 to a variable or something. All right, I should be drawing lines between everything. There we go. There we go. I would complain if you drew one without lines, so I need to do the lines as well. But then I need to squish everything back together. Okay, now we're at the loop. Loops are done in diamonds, just like if statements. While guess not equal to Now, getting all this to fit in one diamond can be a real challenge. So I'm going to wind up using Control Enter in a couple of places to force some line feeds to make it look good, character turns. While guess is not equal to secret number. That doesn't look too bad actually, but I think I want the word while on its own line. So I'm going to put my cursor before the word guess and just hit Control Enter to pop. Nope, that actually looks worse. I'm going to leave it as it was. So the rules for a while is that there will be one line that contains stuff that you do in the while loop, and there'll be another line going off to what you do when the while loop is no longer valid. Just like here, all of this code is done while we're in the while loop. And then this stuff is done after the while loop is done. And the big difference between a while and an if when you're flowcharting it is that an if does not loop back to itself, whereas a while does. Alrighty, so what's the first thing in our while loop? I need to close this one, it's confusing me.
Guessing the input.
Yeah, let's get the input. We don't need all this stuff about print, guess, We kind of skipped this thing that said print, I'm thinking of a number. That's okay. Usually you do your flowchart before the program. We should have done it at the point where we did the pseudocode. Okay, so if the guess is not equal to the secret number, we need to input the guess. Input guess. After we do the input guess, we need to check to see if it's not equal to the secret number. We could simplify this logic so that it did not require nested if statements. However, I'm going to live with it for now. Okay, so I'm coming down here, and this is going to say if guess not equals secret. Now my yes side, I personally always make my yeses go always to the right because that's just like tabbing. The very first thing we do is another if. So I'm going to put another if block down here and make those things hook up like that. If guess is less than secret number, then we need to print too low, else we need to print too high. I think I remember enough about this now that I can fill the whole screen. Too high is on one side of the if block. Too low will be on the other side of the if block. So unlike a while, if statements need to join back together after they're done. So I'm just going to put a little circle down here. It doesn't need that letter A in it, so I'm going to uncomment that A, and I'm going to draw these two lines going back to like that. Now if I look at the way I have formatted this, I have another if statement here, and I need that to join this flow. These statements would be better served if I pushed them over some. So now I need another circle down here for all this stuff to join back. Okay. Now I'm at the end of my code here. Oh, almost. Turns plus equals 1. So I have one more thing, and that's math, so I'm going to put it in a process block. Turns plus equals 1. And that needs to loop back up to the while, because that's the end of the while loop. Now you never loop back unless it's a loop, unless it's a while or a for. Never an if. If statements always have to rejoin at the bottom or something. While loops don't rejoin, they instead loop back up to the top. Alright, then we have some stuff at the very bottom. We wanted to print that they won, and we needed to print how many turns it took. Now ideally I would draw a line straight down, but this code is getting to the point where it can't fit on one page, which is a problem for me because I'm trying to keep it all on one page for you to see. It's not necessarily a problem for you. All right. I know the text is getting a little bit small to read. But all we need to do now is to print out the number of turns. And that they got the guess right. To make room for that, I'm going to grab all of this stuff and move it further over to the right. Like that. And that way I can just have a no line coming down here with a print U1 and another print that says how many turns it took. And then we need a stop. Every one of these starts with a start, every one of these ends with a stop. And of course you can spend a lot of time lining things up and trying to make them perfect, which is not the real point. Doesn't have to be perfect. I can follow your logic, most likely. Bless you. Okay. I hope you can see what's up at I mean, I know you can't see it, what's up at the top, but I hope you know it. There's a start, there's the secret numbers, there's the turns, there's a guess. And then now we have the rest of it. Okay, I hope you see how this matches what you wrote. We had some stuff at the top before our while statement. We picked the random number, we initialize turns, and we initialize guess. Then we have a while loop. The while loop will repeat over and over until they actually get the guess. We had to set guess equal to something different than our secret number so that it wouldn't immediately run down here and print U1. That'd be a real drag. So this -1 is just supposed to be a value that the guess will never match. Then we ask for the guess. We have an if statement. If the guess is not equal to secret, we come over here. If guess is less than the secret number, we print too high, else print too low. Now, everybody wants a block that says else. Not everybody, but when you're looking at this code and you see this else word there, a lot of people wish that there was a word else in flowcharts. If you want, you can change this no to else. But only if it's actually doing something else. This one's not doing anything else. If the guess was equal to the secret, we don't do anything. We just eventually exit the loop. So I'm not changing that one to else. But I am changing that one to else. But you don't have to do that. Just remember that you don't need to put another diamond that says else. All right, I'm going to wander around, eyeball y'all's charts. Let's make a Dropbox for this. We'll be done. Pardon me?
Can you read the flowchart up there for a second?
Yeah, sure. I'm going to increase the size of the font even though it's going to make it go outside the bounds of the letters, just to make it easier to read. All right, well, I can print it out or you could try to follow what's on the screen. All right, who else needs a copy? Okay. I saw one hand. Were there more? 2, 3? Okay.
Do you want the program uploaded with the diagram?
Sure, that'd be great. If you would, please put the program in the chart up there. Bless. And, okay. Yes, sir. Yeah, do download as you can pick either PDF or PNG, just go ahead and do that. Save it somewhere. Save file. Okay. Wherever that is. Okay, yeah. The downloads directory. You wanted one, yes? Some people made improvements to their code, that's awesome. If you did something extra to your program and you want to make absolutely sure I notice it, give you an extra 5 points on it, put something in the comment when you're uploading it. Go ahead and brag. And I do apologize for going fast.
Just trying to switch these
That's fine. If you need to change them, just double click it, the text, and you can make that too high. Maybe I'm not answering the question, but too high was on that side, too low was on the other. Okay. I'm gonna drag some of this stuff out just to give us a little breathe. That's a print statement. Print statements don't grow on diamonds. I'm just gonna delete that entirely. that, you get your own tabs, but that's also kind of cool. See you on Wednesday.
I don't know how I would want to modify this code this time.
The only difference, I mean, the only thing you
Getting
might want to
perfect
do is
score.
play the game again. So put the whole thing in a big loop. And you might want to categorize it so that if it took them more than 10 tries, you call them a name and insult them or something like that.
Basically after 10 attempts, loser, keep going.
Yeah.
Or guess.
Or we can make it bail
If
out
guesses
after
equal
10
10,
guesses and say
if-
you should,
If guesses equals something,
yeah,
you're done.
yeah.
You fell.
You should have gotten it by now. I quit.
I could do that, but I've been getting extra credit on just about everything, so I think I'll just continue working on my object-oriented programming
Good idea.
and classes and things like that.
That is a
We'll
much
get there
better use of
eventually.
your time. Yeah.
Huh?
I said that's a better use of your time
And getting 5 or 10 points.
on something that's silly. Yeah.
That's not silly, it's fun.
All righty. See
I'm
you
actually
Wednesday.
I'm actually learning C# in Visual Studios too.
Oh,
so
cool.
I can learn how to make like a mole shooter game and stuff.
Oh, yeah.
Just for fun.
That'd be cool. C#'s a good language. You could then download the
You need
Unity.
double pi for a constant, but Python doesn't do constants, technically.
Yeah,
They only do variables.
right. So the book
I was
keeps
like-
referring to constants, so I'm going,
I'm
stop
just like,
saying
there is no constants, and then when you typed it at the beginning, you typed double pi, because that's how the constant would be in C#.
Yep, 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 yep,
I'm like, yeah, that don't work.
yeah. Not in this language.
It'll throw a syntax error.
So if you see me accidentally throwing in types, say, don't do that, prof. Throw a book at me. I'll fix it.
I was like, you're classifying something in C# or another language.
Yep. Alrighty.
Yeah.
I don't think we need to save that.
I sent in my P code, the P code too, so I can
Cool.
get credit for that maybe. Even though we did it together. So, is there any specific reason to no class on next Monday? Is just you taking a day off?
I have family business to attend to.
Fine. You getting hang with everything?
Oh yeah, I'm just gonna go study for chemistry.
Ugh, I don't have chemistry. Wait. Where's your computer?
Oh, I was studying last night and I needed to charge it, so I had to leave it at home.
Got it all?
Yeah, I think so. Sent that letter.
See ya, prof.
See ya. See ya.
Thanks for your help on that.
Oh, absolutely. I do apologize that we go fast. I know I can type way faster than most of the people in the
Yeah,
class.
Pick it up a little bit.